Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I am Richard at Richard on the MakeCode Forum.
I'm Joey at J Wonder on the MakeCode Forum.
And today we're going to be working on something a little bit special. So, sorry. Had some water go down the wrong way. We were doing a hackathon this week. Well, some people on the team were. Joey wasn't, but I was. This is where everyone gets to kind of just work on something that they want to, try out new things, try experiments and stuff like that. And so, of course, I was going to do some arcade stuff with this. And so I've been working on doing a thing that I've wanted to do for a long time for arcade, and I'm going to show it off right now, and we're going to be playing around with it today. So the thing that I've been wanting to do is spatial audio. So, Joey, what's spatial audio?
I mean, really, it's just like making it so that the audio feels like it comes from a source that is not just where the thing is positioned in front of you. So like right here, if you're looking forward here, that pink dot would mean that it's going to be like behind you and to the left, I'm assuming, right? That's
well, actually, so yeah, sort of, but we'll get to that in just a second. So yeah, the idea is the most basic form of spatial audio is like stereo, right? You have headphones have two speakers. If something's to the left, you make the thing on the left louder. Something to the right, you make the thing on the right louder, etc. I've been hooking up the audio that we have to all these APIs so that we can actually place things in a audio field, and you can make sounds play from specific sources. So, Joe, you were mostly right about this demo that I have here, except the thing is the listener is the pink dot.
Gotcha. Okay, that's fair. I was like half there because I wasn't sure if that was like the green was the audio range with the
Yeah. You were totally right. It was just flipped. So pink is the listener, that's us, and white is the audio source. And this green that you see here is the radius of the audio range. So right now you can't hear anything because we're not within this radius. But as soon as we move in here, you're going to start hearing something play. And so if you're not watching this stream with headphones on, you're going to want to put headphones on because this is all going to be doing stereo stuff. You need to have two different things. If you're listening over like a laptop speaker, you're not going to be able to hear what's going on properly.
Well, you'll hear the sounds, but you won't hear where the sounds come from.
Exactly.
Or if you have surround sound, just put us on TV. That works too.
True. Yes. I don't think the surround sound will come through the StreamYard, but if you theoretically, when this is merged, if you hook up your computer to a surround sound system, it will work. So if you had like 4 speakers, you would get like different, things coming out of all 4. All right, so I'm going to move to the left here. So we're going to be moving closer to the audio source. And remember, imagine that this is our head, okay? And as we move over here, the audio is going to be coming in our left ear. So you're going to hear it on your left headphone. And then as we move to the right, it's going to be moving more toward the center and then out the right ear and go out the back. So let's try it out. I'm going to head over. So now you can hear it. It's pretty much totally in the left ear. It's kind of quiet. It gets louder as we get close. Now it's switched over to the right ear. Now it's gone again. You can hear it's just playing some song where I just clicked a bunch of random notes.
Nice.
So, yeah, that's the basic idea. Right now, I have not done the blocks for this yet, but I have done the extension. And so the kind of core concepts to think about with this are you have a concept of a listener. So this is the pink dot that we have right here. And then we have audio sources. So that's what the white dot is here. So the panning is done based off of where the listener is relative to the audio source. Now, a fun thing that's about the web audio spatial APIs is they're actually in 3 dimensions. So we're going to only be doing this in 2D. But you could theoretically, if you make a 3D game in arcade, this will still work. There's an X, Y, and a Z coordinates. You can mess those around however you want. All right. So let's take a look at the code that we have going on here. So first off, I'm creating well, let me comment out the bits of code that aren't actually being used in this demo. Yeah, okay. This is good. So we have we're creating an audio source right here, and then we're getting the listener. So there's only one listener, right? There, you only have one set of speakers, one set of surround sound. And then we're creating a sprite. So this audio source sprite. So this is just so that we can see where the audio source is. That's the white dot here. Then we're defining a radius. Now here we're setting some options on the audio source. I'll get there in a second, kind of going into what these are doing. And then finally, we have a song that we created, and we're calling play at location and passing in our audio source. We're doing looping in background. So this is just continually playing this at the audio source. And finally, we have this is where we're creating the pink dot that's moving around. And inside of this on-game update, we're just setting the listeners X and Y to be the sprite XY and the audio source XY to be the audio source sprite XY. So pretty simple program. So what were those other things I kind of skipped over? Well, we need to talk a little bit about how audio sources work in web audio. All right, so they have a number of parameters. So the first most obvious set of parameters is the location, right? So there, like I said, there's an X, Y, and Z. In this case, we're only setting the X, Y, but that is the position of the thing relative to whatever the listener is. Now, additionally, we also have orientation X, Y, Z. So this is a vector which tells you which direction it's pointing in if it was facing in 3D. Now, I don't think too many people are going to use the orientation. I did surface it, but you can use it if you want. So what this would be like is, if you imagine you're holding a boombox above your head, right? As you move your head to the front, or if you tilt the boombox to the side, it's going to sound different, right? As this thing is twisting around in space, because the boombox shoots sound out the front. So if you tilt the front away from you, it's going to be quieter. Tilt the front towards you, it's going to be louder. So that's what the orientation is for. Next, so like I said, I don't think too many people are going to use orientation, but you can if you want. Next thing that kind of goes in with orientation is the cone settings. So you can also think of the sound as having two cones where it's emanating from, okay? Imagine a light beam coming out of a spotlight, how it kind of spreads out. And so that's where your sound is coming from. So every audio source has two cones. It has an inner cone and an outer cone. And the way it works is the inner cone that's extending out from it, everything inside the inner cone is going to play at full volume. And then everything outside the outer cone is going to start attenuating. Okay? So the idea is that you have two cones, one where it's just going to keep playing at full volume, and then one where it's going to keep playing at, it's going to start dropping off the volume. So these cones are only useful if you're using orientation. So if you're not using orientation, you can just set both cones to be 360 degrees, which just means that it's all around you. So if you want to use the orientation, go for it. You're also going to need the cones to set what is your what is the amount of spread you want on the sound. We're not going to use that today because it's really only useful for if you're using that orientation, which we're not. Maybe we'll do a demo of it. I don't know,
Can we do a sneaky game with that? But instead of field of view, it's field of hearing.
Sure,
we could. Kind of reversed. Well,
I mean, so what our goal is today is we're going to be making a game to show this off.
Yeah.
So I figured we would just do the basic thing first, which is just making a tile map and then putting a bunch of sound sources in the map that you can walk around,
Yeah.
But we could also do something where we do it directionally. We could do it if a speaker is up against a wall, we could make the speaker point downwards so that if you go on the other side of the wall, you can't hear it,
I like that.
So we'll play around with all of that. All right, and then the final kind of set of parameters are the distance parameters. So you can set a radius, which is how far you want the sound to be audible, right? So I have this set at 30 right now, which is 30 pixels.
Mm-hmm.
So if you go outside 30 pixels, you can't hear it anymore. You can also set the distance model. So I'm setting the distance model as linear, which is the easiest to use. There's also inverse, which I do not understand, and exponential, which just has an exponential drop-off. But linear is the easiest to understand, so that's what I'm using. And the linear, it just linearly gets quieter from the source to the edge, right? Mm-hmm. And then finally, we have set roll-off. So set roll-off takes in 3 parameters. One is ref distance. I don't know what this is, what this does, I'll be honest with you. But it's 1 by default. So I am just passing in 1 here. The second option is that radius we were talking about. And then the third option is the amount of roll-off. So 1 means the sound gets completely silent when you're outside the range. But if I were to put in like 0.5, then when I get outside the range, it's now going to be at half volume forever. Right? It'll get louder if I go back in. Okay. So by default, you want it to be 1 if you want it to actually stop playing at a certain point. 1's the maximum value when you're using linear. When you do exponential, I don't really know how to make everything work. So if I put an exponential here, then you'll see it definitely drops off way faster, which you would expect with exponential. But it doesn't get fully silent when you get to the edge of the radius. It's like silent earlier, and like if you have it be louder, I don't know. I was getting some weird results from messing around with exponential. But you know what? Give it a shot, play around with it. If you figure out how it works, let me know. I would love to know. So we're just gonna be sticking with linear today.
Was this is this just directly from the web audio APIs, or is it?
Yeah, I'm pretty much just surfacing the parameters directly. So
gotcha.
All right. So this is it. I don't have blocks for this done yet. I will do blocks for it. Don't worry. There will be blocks. But for now, what I've done is for all of the playable types. So playables, we kind of went through them last stream, but it's all of these like play blocks that we have. So like play melody, play song, play sound effect, all of those. They all now have an additional method called play at location. And if you pass in an audio source, it will play that playable at that location. So I am playing this song at this audio source and just having it leave the background. So yeah, all right, that's where we're at. And with this, let's go ahead and start making something. So I'm just kind of imagining a game where we like walk around a spooky house or something, and there's like a bunch of things like making sound. And we can kind of decide what we want to do beyond that. But for now, I just want to have a demo that shows everything off.
Yeah.
Right? So let's start a new project. We're going to call this Spatial Audio Demo. There we go. And we're going to go ahead and start by just coding a regular old game. We'll add the spatial audio stuff afterwards. So we're going to go ahead and make a tile map. You know what? Let's do 8x8 tiles. Let's see. Arcade.
You said like a spooky house is your idea for the theme for this one?
Yeah. I was trying to think of like what's something that we could have like a bunch of different sounds around.
Yeah.
But I guess it could also just be a non-spooky house. We just need to have a lot of different like individual things to walk near, you know?
Yeah. Well, I like spooky house because then it'd be fun because then we could do like there's a ghost walking by, so you hear wailing and you
sure, yeah. And then I was like, there could be a TV that's just showing static, plays static sounds when you get close, and like an old phonograph, which is just playing a spooky song or something.
Yeah. It's a good idea.
Yeah. All right. So we're going to go ahead and do set tile map 2, and we're going to create a tile map. Whoa. What the heck? Oh, man. Okay, wait. 8x8 tile maps might not work in beta. We're not going to use 8x8 tile maps. We're just going to use regular tile maps. There's some broken stuff in beta right now. I need to go in and fix it, but it's fine. All right, let's go ahead and make some planks. This will be our wooden floor. Fill that in. All right. Make some walls. So we're gonna do just some purple walls, and then I want to do like the trim, basically, like this. And we can decide if we want to make them more fancy later. But so we'll just go ahead and do like this. And then I want to make some, I basically just want to rotate this around and then make some corners. All right, make some corners. This is going to be, so when you're doing corners, you typically want to do at least 4. If you're being fancy, you can do like more like 8, but we're just going to do 4 right now. There you go. Put that in like that. Wait a second. I did too much. See, goes like that, and then you can just continue the wall up like this. This isn't going to win any awards, but, you know.
Yeah. I mean, the main point of this game is not the visuals in the first place.
No, yeah. It's just to show off the APIs. Okay. Rotate, rotate, rotate. Whoops, didn't mean to hit new. Delete. Yes. Duplicate. Rotate. There we go. And we need to just create a black tile, which is going to be our nothing's here tile. So put it like that. There you go. All right. So let's go ahead and just do the outer walls. Whoops, that's backwards. I want to do it like this. One again. There we go. Oh, wait, I have to do the inner walls, don't I? All right, well, might as well. Like that. All right. So let's start with something we definitely want to have, which is we want to have that TV with static. I guess we also definitely want to have like the ghost walking around. It's a really good idea. But I think it's static is at least, it's pretty obvious how we make that sound. So
yeah, I don't think we have a nice woo.
Yeah, we'll have to, we can definitely make one, but we're going to have to, make it. So let's go ahead and draw a quick TV. So we're going to do, whoops, this and this. I should give it an antenna. Let's actually just make it a bit smaller so that we can do this. That. And we're going to put in a screen. A little bit of glare like that. That's the little extra room right there. Put a button. Actually, let's do that. There you go. Looks more like an original Macintosh than it does a TV, but it'll do the job today. So we'll just go ahead and put that guy right there. All right. And we're going to fill in the background behind with brown. Okay. Cool. So let's go ahead into our game. And we're going to go ahead and create our character who's going to be walking around. So I might go in and make an actual character later, but I'm going to make I'm just going to use, oh, right, the gallery is broken in beta too. Yeah, I'm sure I broke all of this with the asset editor changes I made recently.
Oh.
So I was just going to do the duck, but I guess now I'm forced to draw a dude. So let's do it. There you go. We're going to do 12 by 12. And let's see, he's going to have a rad hat. That. Put a label on the front. Go. Let's see. He's wearing this hat sideways because he's a real cool dude. Let's do this. I don't know. Maybe I will make him in profile, actually. That. So I can give him some hair. Give him a purple shirt. Give him little legs. Little feet. This guy's so stubby, I hate it.
I mean, they're pretty normal sized legs in comparison to his body, I feel like.
In comparison to his body, true. All right, we're gonna make him taller. I can't have this guy be quite this wide in proportion to his. There we go. Give him some hands. Give him like a, I don't know, like a belt or something. And we got to put something cool on his shirt.
How about the number 1? Just because he's number 1.
All right, he's number 1. There we go. That's our guy. All right, so we can move our dude around. We're going to go ahead and make the camera follow him too. And I'm not going to bother doing walls yet because we'll do them later. But for now, this is good enough. All right, so
kind of messed up to steal the he's actually the ghost all along.
Yeah, that's not my plan, but you know, maybe. Okay, wait, I want to make him skateboarding inside. All right, we're gonna make him 18 tall, and we're gonna give him a skateboard.
Okay.
It does not really come across as a skateboard, but good enough. There we go. Skateboard. No, that's terrible. All right, back to just being a normal dude. All right. Okay, did that just kill my tile map? Cool.
Wait, what? Oh, that happened.
No.
Does Time Machine have it?
Probably. Let's see, 124. That was 5 minutes ago. All right, good enough. Got to redraw my dude now. If anyone can find out us like a way to repro that bug consistently, I will be forever grateful if you could send that our way. We've all had it happen, but it's really hard to do in a way that I can actually do consistently so I can like debug it.
Mm-hmm.
Who's number 1? It's this guy.
Ooh.
There you go. Looking slightly different than before, I think. That's okay. Move with buttons, camera follow.
I guess we could make this guy number 2 now, but maybe that would just be a little bit mean.
That would be kind of funny. Yeah, he's number 2 now. All right. This guy's definitely squatter than the other one was. Okay, so we're gonna go ahead now and do our basic static TV thing. Okay, so we're gonna replace this tile with a sprite. So let's actually go into tile util. We're gonna go ahead and do on tile map loaded, and when tile map's loaded, we're gonna go ahead and do. Whoops, I want to do cover all. We want to cover all of our TV tiles with the floor. And then in its place, we're going to go ahead and create a TV. So do for element value of we're going to go ahead and do inside of scene, array of all blank locations. Right here. Make this our TV location. Add a new kind, TV. New variable, temp sprite. And then in here, we're going to go ahead and draw a TV. And now I can actually draw a TV that looks okay, make it slightly bigger. So we're going to go ahead and do mostly like we did before, which was to draw this box. I'm going to round it out a little bit. There we go. Going to make it have that 3D thing going on. This. Beautiful. Give it a little foot like that. Go ahead and draw our screen. You know, youngins this day probably never had CRTs, right?
I'm sure they're still using them just for the Smash Bros.
Sure. Smash Bros. You just don't know how it was back in the day when it was the only option.
Mm-hmm.
All right. And to make it obvious it's a TV, obviously you have to give it bunny ears.
Mm-hmm.
There you go. That's a TV. Okay, we're going to go ahead and copy this, and we're going to make an animation. So go into animation, do animate frames, do this temp sprite, do loop on, paste this in here. Let's see, it was 24 by 24, I think. There we go. And we're going to do a static screen. So we're going to go ahead and paste this as white. And we're just going to put in a bunch of, here, let's duplicate this a few times. And we're just going to put in a bunch of
void.
Yeah. And do the next one. I don't know. Maybe we should just do this programmatically.
It's kind of fun to do it programmatically.
Yeah, let's just do it programmatically. Okay, so we're going to go ahead and do extensions. We're going to do jwonderl/arcade sprite util. And we're going to pull this out. And we're going to go into scene and do, sorry, not scene. We're going to go into sprite utils, grab a render on z-index. And then we're going to do for all of our locations. So let's go ahead and pull this in right here. We are going to go ahead and draw our TV at this location. So we're going to start by doing inside of sprite utils, we can go ahead and grab draw image. So this is actually now in the image category also. Put in screen. And then for the location, we're going to go ahead and grab the location block. Stick that in there. And because this is slightly bigger than the tile is, we need to, we're going to make this left. And we're going to subtract, let's see, so it's 8 bigger in both directions. So we're going to make this be -4. And then do the same thing for the top. So left -4, top -4. Great. So we should now be drawing, there we go. Oh, we're not drawing relative to camera, so it's just stuck to the bottom of the screen. So let's make sure we do that. We're going to go into our math, grab another minus block, go into scene, grab the camera block, change this to left, and then stick that in there. And then do the same thing with the top, except we're going to be subtracting the top. Okay. Now it's drawing in the right place. Great. Okay. We need to make our antenna black. There we go. Whatever. Okay. So we want to make this staticky. So what we're going to do is we are going to loop over our screen. So we can see our screen goes from, let's see, this is 5, 8. You can see in the bottom left, the location, 5, 8. And it goes to 16, 19. And make two variables now. We're going to call them index x and index y. And we're going to do a nested for loop. So we're going to go ahead and put this in here, duplicate. Oh, wait, these are for up loops. Oops, I want to do a for index here. Duplicate. We're going to change this one to be index x, change this one to be index y. And let's see, I already forgot the numbers I said. So it's from 5, 8 to 16, 19. So it's 11 by 11. So we're going to do from 0 to 10. And we're going to do an if right here. Go into images. We're going to do the color at. And we're going to go ahead and grab our TV image, put that right there. And this is going to be 5 plus our index x. And then I think it was 9 plus our index y. And we want to check if that is teal, which is color number 6. I knew that. I don't know why I looked it up just then. Okay. So if it is that, then we want to randomly set it to be either black or white. So we're going to put in a logic here. We're going to do an if. We're going to do a math 50% chance. So right here. Not 500%. And we're going to go into images and grab the set color at. Going to make this the screen. And the location we're going to be setting is going to be equal to all of this junk plus 5 plus index x, like that. And then this is going to be top minus 4 minus camera top plus 9 plus index y to white. And then we're going to go ahead and duplicate this, put it in the other one, and do black. All right. Let's see. I bet you we have an off by 1 error. Nope. Got it right. No. There we go. All right. This is not, doesn't look great, does it? I don't really know what I was expecting. Maybe we want to do like,
Is it, I mean, it's changing to how to make recognizable TV static programmatic.
I mean, I feel like what we want to do is like it's not when you see static on the TV, it's not like individual pixels, right? Like I feel like we want to do like 2 pixel chunks or something.
That would make sense.
So we can do that by doing this from 0 to 5 instead. And then we want to do in here, we want to multiply this x by 2. Keep the y at 11. Like that. And then we want to make this be 6 plus index x times 2. And then do the same thing here. This is not going to work exactly, but we can at least see what it looks like. Make these both black. All right. Okay, I do think,
I think that would look better. I like that more.
Okay. Why is it off by
2?
Oh, I know why it's off. So we're doing this color at 5 plus index x. This should be index x times 2, I guess. It's still going to be wrong for there. And then it goes off. It goes too far because we're doing 2 and it's an odd number. All right. We're spending too much time on this. Let's just go back to the simple one.
That's fair.
Make it look better later. All right. Right. Change this back to 10 and 10. All right, there we go. Okay, so we want to make this make a staticky sound when we get close to it. So we're going to go into JavaScript now, and we're going to do for, and we'll do const location of, let's do this inside of our map loaded. Tiles.all get tiles by type. And then we need to pass in the tile image. Shoot, I guess we'll just go to assets and see what it is. It's my tile 14. Oh, wait. Oh, right, it's right here. We're going to do const source equals new music.spatial audio source. We're going to do source.x equals location.x, source.y equals location.y. And then we want to do, let's see, source.set rolloff. And we're going to set this to be 1. Our max distance is going to be 30 again, and our roll-off factor is going to be 1. And then we're going to do our actual sound. So for this, we're going to go ahead and add the sound instructions extension because that's easier than anything else. Self-plug here. All right. And we're going to do const my sound equals sound.create. And then we're going to do my sound.add part. So the waveform is going to be sound.waveform.white noise. Frequency doesn't matter. Volume is just going to be max. Duration is going to be 1 second. And then we're not going to worry about the end frequency and end volume. And then we're going to do control.run in parallel while true source.play instructions my sound.render volume is going to be music.volume and frequency scale is 1. And we need to pass in a time, which is going to be 0. And then we're going to pause for 1 second. All right. Well, that didn't work. Okay, let's see what we did wrong. So we have our sound. Let's make sure we can play our sound. So we're going to do just controller.a.onEvent, controller button event dot pressed, and then do my sound dot play. All right. Oh, we're not moving the listener. Duh. Game.onUpdate. Music.spatial.getListener.x equals mysprite.x, and also set the y. All right.
Spooky.
Cool. That works. All right. So let's do the next one. We're going to go ahead and do our ghost now. So let's head on over to assets, and we're going to do edit our tile map, and we're going to put in a ghost.
Spooky.
There you go. That's ghosts. All right. Let me copy this image. Okay. And we're going to go ahead and do plus image, paste this guy in here. Ghost, wost, ghost. And let's go ahead and name this tile ghost tile also. Cool. All right, head back over to JavaScript. Okay. So now we want to go ahead and create our we want to go ahead and create our ghost sprite. So we're going to go ahead and cover this tile up just like we did the other thing. So we're going to go ahead and paste this in here, make this be ghost tile, and then we're going to do a loop over this, make this ghost tile. And we're going to go ahead and do const ghost equals sprites.create assets.image ghost, and then ghost.x equals location.x, and ghost.y equals location.y. And then we're going to do sprite utils dot add or sprite utils dot on sprite update. There we go. And we're going to do our ghost. In here, we're just going to do, let's see, if ghost.vx equals 0, and ghost.vy equals 0, then we're going to do const direction equals randint 0 to 4, and we're going to do oh whoops, I'm going to make this be sprite. There we go. We're going to do sprite utils dot move to @speed, and we're going to move our sprite, and the location is going to be let's see, tiles.location.get. Let's see, is it I want to get the location in direction. I don't actually remember what the thing is for that. Let's see, tiles dot. Let's see. Let's do sprite dot get location.
Is it easier to look in the toolbox?
Here it is. Get neighboring location. And then we're just going to pass in that direction.
Oh.
And then for the speed, we're going to do 20. Okay, let's see if that worked. All right, we should have a ghost just wandering around. There he is.
Oh.
Yeah. Nope. Crashed. I don't know what that was about. Okay, should probably check.
Hey, copies, right?
Console, move to at speed. Okay. Oh, I'm guessing this get neighboring location, we're passing in a direction it can't actually move to or something. Oh, we're doing 0 to 4. This should be 0 to 3.
Oh, okay.
Okay. Well, anyway, this dude's moving around now. Copysprite says, "Can you try playing this, please?" At some point. Yeah, we'll play it in a sec. All right, so we want to go ahead and make this ghost make some spooky sounds. So, Joey, can you do an impression of a ghost for me?
Ooh.
Yep, that's about it. So we're going to go ahead and do const ghost sound equals sound dot create. We want to do ghost sound dot add part. Waveform is going to be, we'll just do sine. So we're going to do sound dot waveform dot sine. Frequency, we're going to do kind of low, so we'll do like 100 hertz. Volume, we're going to do 1024. Duration is going to be a second. In frequency is going to be slightly lower, we'll make it 90. In volume is going to be 0. And actually, we kind of want it to like start at 0 and then go up and then go back down. So we're going to add a first part here, which is going to be, we're going to change this to, yeah, we'll leave this at 1,000 each. And we're going to make the volume for this one 0 and go up to 1024. And we're going to just make this one be 100 and make this be 9. All right. And we are now going to go ahead and do ghost, let's see, control.run in parallel while true. We're going to do, we need to create an audio source. So we're going to do const audio source equals new spatial music.spatial spatial audio source. And we're going to give it an X and Y. So audio source.x equals ghost.x and audio source.y equals ghost.y. And then in here, we're going to go ahead and do audio source.play instructions, ghost sound, put it in 0, and then ghost sound.render, music.volume, and then the frequency scale is 1. And then we're going to pause for 2.5 seconds. Okay. So this should now be. You can hear it, right?
Mm-hmm. It's pretty ominous.
Yeah, it's not quite what I'm looking for, though. So we need to make sure we're constantly updating this, by the way. So let's go ahead and put this inside of, well, we'll leave that there, but then we're also going to put this inside here. It's like, I guess now it should actually be with this. Okay, and we want to put in a roll off just like we did for the sound. So for the stack. So let's go ahead and put that in as well. I'm just going to copy the code. Where did we do that? There, roll off. put this as our audio source, like that. And I want to kind of make it be a higher frequency. So let's make it be like 400. And make this be 300. And then do 400 to 300. And we're going to go ahead and apply a modulation as well. Or it's going to be sound dot apply frequency modulation on our ghost sound. The modulation is going to be sound dot create LFO. We're going to do sound dot LFO waveform dot triangle. We're going to get a period of 100. We're not going to bother with the phase, and the amount we're going to do is going to be sound dot semitone scale factor of 5. All right.
Pretty ghosty.
Yeah, make this more like 1, I think. There you go. That's a ghost sound, right?
Yeah.
Maybe make it 2. Or let's do 1.5. Cool. All right. So anyway, this is the beginning of our game. So I'm going to keep working on this. I'll probably do some better art, and on Friday I'll demo the finished thing, because I'll have, you know, all of this kind of like ready to go. I've got all the APIs done, so I just need to do this demo so I can show it off to the team. All right. So in the meantime, we have a game to play. Joey, can you send me that?
Yeah.
Oh wait, no, I got it. I got it actually.
Oh, okay. Is the stream about to? Yeah. Yeah. Well, we're playing
All
your
right.
game first.
Cacti Chaos by Copyspread. Like the name. Ooh. Got him. Do these cacti have exposed brains, or are those flowers?
Or both. I mean, maybe the brains are flowers.
Could be. Oh,
Nice.
flowers. Got it. I'm going to say you could label these as zombies, and... Oh, nice. I've got an upgrade. Oh, man.
That's speed up.
Love the mustache cactus.
Are the upgrades random or?
Oh, my God.
Oh gosh.
This very quickly increased in difficulty.
Yeah, it's supposed to be like a hat. Yeah, I mean it's good. We like them, even if they're whether they're brains or flowers. They are good.
Yes. Upgrades are not random. Oh my God.
Okay.
I just kind of have to like circle to bundle them up and then take shots where I can. Okay, dead. Let's try it one more time.
Nice, nice.
All right. Don't let them build up this time. What is the when I press the B button, something happens. So what
it says?
Oh, it is? Gotcha.
Yeah. Nice. Oh.
I'd say Copysprite number 1 on my feature request would be to be able to hold the shoot button.
Are you going to? Are you planning to add anything else for the upgrades? It'd be fun if this had like one of the pick 3 systems where you have like 3 things pop up and you're like attack up, attack speed up, or shooting lasers.
Yeah, like a perk system, like Vampire Survivors type thing.
Yeah,
that's cool. It's a good start to a game. I like anything cactus themed. That's for sure. I like that you can heal. Oh, there are 10 upgrades in the game.
Okay. Nice.
I'm gonna look at the code.
Yeah. I also like your multi-color text throughout all of it. Looks like.
Mm-hmm. All right. Also, the game is infinite. Cool.
Oh, nice.
Let's see. Upgraded. Okay, these are just show the upgrades. Press takedown. All right, here we go. So this is where we get the upgrades. I see. So you can end up getting more health, more attack, ooh, more projectiles, healing up, attack damage. Oh, very cool. Oh man, you should look into using the fancy text extension, though I do applaud your effort in writing all of this text out. Though the fancy text extension does not allow you to have the fancy colored text that Joey was complimenting before.
Did you not allow? I thought you had two-tone.
Yeah, you can have two-tone, but you can't have anything beyond that. So.
Okay. That is nice. If you do run into problems on, like if you're trying to get this on hardware, you probably will have to do either the fancy text extension or just go in and trim out all of the white space in that image.
Yeah.
All 160 by 120. If you do it as just the top left corner, that'll make it feasible to hit on hardware, even if you have a lot of them.
Yeah, you're going to want to crop these because if you add more, or like Joey said, you're trying to go on hardware, all of this is just wasted space. And eventually it's going to get to where you can't share the project because you have too many of these full screen things.
Yeah.
So because you're just drawing them in the top left anyway, you should be able to just, crop this out, just draw it there.
Yeah.
Last thing I should mention, since we were talking about hardware, all of the spatial audio stuff I was doing, I just kind of assumed this was obvious. That is browser only. The spatial audio stuff, all of our arcade hardware is mono, even the ones that have headphone jacks, as far as I'm aware.
That makes sense, yeah.
At least the only one I tried was the Pi Gamer. The Pi Gamer is definitely mono, even in the headphone jack. So,
and I would assume that Pi Gamer is one of the.
Yeah, and I mean it's definitely
speakers
definitely mono. There's only one of them, so. All right. Thanks for watching, everybody. Tune in on Friday. We'll have like a bigger demo of the spatial audio stuff, and we doing some other fun things. I am Richard at Richard on the MakeCode forum.
Joe at J Wonder on the MakeCode forum.
And we'll see you later. Goodbye.
Bye.